Good morning, you guys. How's it going? All right, we're going to start a new lesson. We're still in chapter 7, and this is Algebra 2 General. We're doing 7.4 Properties of Logarithms. So if you've copied the notes or if you're looking at the notes that are posted in Focus, we're going to be doing the first page and then just this top piece of the second page. All right, so let's go ahead and start on the first page. Now, logarithms, as you can tell, is something totally new. You've never done logarithms until Algebra 2. This is really important that you understand logarithms before you go into your next higher level math class. So it's really important that we cover this before we close out this school year. So we're going to cover some stuff in Chapter 7. We're going to cover some stuff in Chapter 8. And then we're going to start reviewing for the final. All right, so today is, look at my calendar here, okay? Today is, it is the 20th. It is April the 20th. I think today might be Earth Day or something. All right, so I'm going to put April the 20th up here. Oh, 2020. All right, use properties of exponents to simplify each expression. So we're going to review what you do with exponents before we start talking about what you do with logs, because it's going to be really kind of different. Now, when you are multiplying exponents that have the same base, what you do is you add the exponents. All right, so that's x to the 7. What you do when you're dividing exponents that have the same base is you subtract the exponents. So that's x to the 4. What you do when you're multiplying exponents, you literally multiply the 4 times the 3. So 4 times 3 equals x to the 12. Now remember, this is another way of saying I want to take x to the 4 and I want to multiply it by itself 3 times. So if you do it that way, you're actually bringing it back to what we did at the beginning, where you're just adding the exponents, 4 plus 4 plus 4. But we don't do it that way because that's the long way. So when you have the parentheses, you're multiplying those two exponents. All right, because a logarithm is an exponent, logs and exponents have corresponding properties, so they're similar. All right, these are the properties of logs. Now, this chart right here can go both ways. I can start from the left and move to the right. That's called expanding. Okay, we're going to do that tomorrow. What we're going to do today is we're going to start from the right and we're going to move to the left. That's called condensing. Now think about it. Look at this. If I'm starting at the right, we'll look at the first one, which is product, okay? If I'm starting at the right and I want to change that to look like something on the left, can't you tell it's condensing? It's getting smaller. It's not taking up as much room. You have plus signs in between when you have something that is expanded. You have minus signs in between, and you have a coefficient out in front. All these on the right-hand side are considered to be expanded logarithms. Okay, on the left side, let's change colors here a minute. On the left side, these are logarithms that have been condensed. So what we're going to do is we're going to start, our problems are going to look like the red part on the right, the expanded version. We're going to take the expanded versions and turn it into the blue part on the left, the condensed version. So now I want to go and explain what these properties are. All right, since we're going to go from right to left, I'm going to explain it that way first, and then tomorrow I'll go back and explain it from left to right. If you are being given this right here, and you see the plus sign in between, I'll trace over some of these things as I'm saying it. You see the plus sign. You see that the bases are the same. But this plus sign right here tells you that you're fixing to multiply the m times the n. Now look on the left. The log stays the same. The base stays the same. And you're multiplying m times n. Now if m and n are numbers, you can multiply it more. But if m and n are just variables, they're going to sit just like that. Okay, so that's the product property of logarithms. Okay, if the bases are the same and there's a plus sign in between the logs, you're going to multiply the arguments. All right, now let's look at the next property. We're going to start on the right. I'm going to assume it's already expanded. We're going to look and see that the bases are the same. We see there's a subtraction sign. And we see we have an m and an n right after each log. Remember when we were doing them last week that we would read it like this. Log base b of n is, and we would write that it would be the exponent. Okay, so this m and n that we're writing is the of part that we were writing last week. Okay, just to refresh your memory on that. All right, now think about it. If the one above we were adding and we ended up multiplying, this one we're subtracting, so what are we going to end up doing? Dividing. Okay? All right, so that's the properties of logarithms when you are condensing it. All right, let's look at the last one, the power. This is considered expanded when you have a coefficient out in front. You see that the rest of the log looks like log base b of m. We're used to seeing that. Now all of a sudden there's something out in front. This is the expanded form. All right, so when we're going to condense it like we just were, we were going from the right side to the left side. That's condensing it, making it smaller. All you do is take that p, which is your coefficient. That coefficient ends up being put as the power, in this case, for m. So let me get another color going. Excuse me here. This p ends up going right here, and it becomes the power or the exponent of m, which is called the argument. Okay. All right, let's see if we can practice some of this, because the practicing is what makes it kind of make a little bit more sense to you. Okay. Write each expression as a single logarithm. Now, they didn't even have to say that. They could have just said condense, and that would have been enough to know that we're going to make the log base 4 of 5 plus log base 4 of 2. We're going to make it more concise. It's not going to take up as much room, so we're condensing it. Now, the first thing you always check is, are the logs the same? They are. I see a plus sign. So what you want to do next is you want to write log base 4. All right, so you've taken care of your log base 4s. Okay, now you're looking at the plus sign, and you know when you see the plus sign, you're going to multiply. So what are you multiplying? You're multiplying the 5 times the 2. So you're going to have log base 4 of 10. That just got condensed or simplified. We're writing it as a single logarithm. All right, that wasn't too hard. That one was like the product one, okay? Where you had the log base b of m and the log base b of n, and you ended up multiplying them, okay? All right, let's do this again. But look, do you see this 3 out in front? We didn't have anything out in front. Anytime you see something out in front and you are getting ready to condense or simplify or write it as a single logarithm, you've got to take that 3, which is the coefficient. I'm going to circle it over here on your right in blue. It's like the p. And you're going to take it and you're going to make it become the exponent. So this 3 right here is going to become the exponent of that 2 right there. So I'm fixing to rewrite it and make it look like that. So the coefficient becomes the exponent. All right, so let's write it like this. Equals log. Now this is really base 10. Remember, when you don't see the log, it's really a 10 there, so that's called a common log. So log base 10 of 2 to the third plus log base 10 of 4. Now, you don't have to say that base 10 part. I'm just saying it to get you back used to it in case you hadn't really thought about it over the weekend, right? All right, so now we're going to have to simplify the log 2 to the third. So you know that 2 times 2 times 2 is what? 8. So I'm showing you every step. All right, the next thing you're going to do, since there's a plus sign, is you're going to multiply the 8 times the 4. That's called the argument. That's the work. So what is 8 times 4? That's 32. And do you see how you've simplified it? You've condensed it. You've written it as a single logarithm. All right, let's go to C. So the first thing I go do is I go look in front. There's nothing there. There's nothing there. Oh, there's something there. I've got to go change that coefficient and put it as a power. All right, so we're going to do log base 5 of 2 plus log base 5 of b to the 4th plus log base 5 of 3. All right, so now I've taken the coefficient and I've put it as an exponent or a power. Now go check, are your bases all the same? Yep, they're all log base 5s. Well, what are the signs? They're all plus signs. So that's going to be multiplication. So we're going to write log base 5, and we're going to multiply the 2 times b to the 4th times the 3. So now we have log base 5, and I'm going to do the 2 times the 3 first. And that's going to be 6. And then we're going to do b to the 4th. And that's your answer. Now, if you want to put this in parentheses, you can, but you don't have to. All right, let's look at D. Anything in front? Nope. But this time, hey, it is not a addition problem. Now, look out in front. Put a plus sign there if you have to, because this is letting you know. The plus sign is telling you, hey, I'm getting ready to multiply it. So we're going to do log base 3 of 6. Now, I said I'm getting ready to multiply. Well, I thought I was getting ready to multiply it, but that plus sign for this problem tells me that that 6 is going to be the numerator. So I'm going to go write it a little bit smaller. I'm going to put the 6 here. Because that minus sign tells me I'm fixing to divide that 6 by something. That plus sign tells me that the 6 belongs in the numerator. That minus sign tells me that I'm fixing to divide and that this is going to go in the denominator. So log base 3 of 6 over 12. Now, normally we put fractions in parentheses. Like the problem before, I said you could put that in parentheses if you wanted to, but I usually don't. But when it's a fraction, you want it in parentheses. Now, the only thing you have to do now is just reduce the 6 over 12. Log base 3 of 1/2. So remember, when the plus sign's in front, that tells you that's the numerator. When the minus sign comes next, that tells you that's the denominator and you're dividing by it. All right, let's look at E. All right, do you see automatically it has this 1/2 here? I can't have that there. I've got to move that. I cannot have a coefficient when I start trying to condense a logarithm into a single logarithm. So we're going to do log base 7 of 64 to the 1/2 minus log base 7 of 2. Take each step and do it one at a time. Now, I want to refresh your memory on the 64 to the 1/2. All right, remember that's going to end up being a radical. You take the 64 to the 1 and you put it under the radical. The 2 becomes the root. All right, so now I'm going to erase all this scribble scrabble so I don't confuse you. Change this to red. Now, you don't really need a 1 there, and you don't really need a 2 there. What is the square root of 64? It's 8, right? Okay, so we're going to change that 64 to the 1/2 to 8. So log base 7 of 8 minus log base 7 of 2. All right, so we got rid of the coefficient and we made it a power. Check. And then we got rid of the fraction. We don't want to leave a fraction as an exponent. We don't want to do that. All right, now we can write it as a single logarithm. So since this first one really has a plus sign in front of it, it's log base 7 of the 8 is in the numerator. Now, the reason why we know we're fixing to have a denominator is that minus sign. That minus sign tells me all this right here is fixing to be in the denominator. So log base 7 of 2. All right, so I'm going to put parentheses around this, and now we're going to simplify. Log base 7 of 4, and that is our single logarithm. We condensed it. All right, F. First thing we want to do is go get rid of all those coefficients. So look in front and look in front, and we got to take care of business right there. All right, so let's do log base 10 of 8, or we could just say log 8. We know the base is 10 to the 2/3 plus log of x to the 1/2 minus log of y. All right, so we've taken care of all the coefficients and we turn them into exponents. Check. Now we can see that all the logs are base 10, so that's a good thing. So now we're going to have to go and change the square root, the fractions into square roots. All right, so I'll do that above it. So 8 to the 2/3 is, take the 8 and to the 2 and leave them together. They go under the radical. The 3 goes on the outside. Now you know that 8 squared is 64. So what is the cubic root of 64? So in other words, what number times itself 3 times will give me 64? Boom, you're right, 4. So this is going to be log 4 plus log. Now this x to the 1/2, I'm kind of looking ahead and I'm thinking, you know, really there's not going to be much that I can do to that x to the 1/2. So we can wait to do it or we can do it now. I'm going to go ahead and do it now. So x to the 1/2 is going to be x to the 1, and then it's the square root. So it's going to be a 2. So we don't really need the 1 and we don't really need the 2. So we're going to leave it looking just like that, the square root of x. And you'll see in a minute that it's going to end up staying looking like that. And we're just going to bring down minus log y. All right, now if you look at the other problems, besides, I guess, C, we have been working with 2 logs. So let's do pink. See, here's one, here's one. Here's one, here's one. Here's one, here's one. Here's one, here's one. This is the only one right here so far until we got to this one that we were working with 3. Now, just want to go back and look at this. This is a plus sign. This tells you I'm multiplying, I'm multiplying, I'm multiplying because plus signs follow it. This is going to be a little bit different. Okay, so let's look in front. There's a plus sign. All right, so I'm going to start out with multiplying. So I'm going to say log, and that 4, because I'm looking ahead and I'm seeing there's a minus sign, that means I'm going to be dividing something. That means I'm going to have a fraction. So since the plus sign is in front of the 2/3, I know that the 2/3, actually the 4, because we changed it, okay, we know that the 4 is going to be multiplied by something. So I'm going to put the 4 in the numerator. All right, now we got to look at the second one. Is there a plus sign here? We could also look down here if we wanted to, right? We could go add these if you wanted to up front. There's a plus sign for the second log. So I'm still multiplying. So I'm going to put the square root of 4, I'm sorry, the square root of x right by 4. All right, now you see this minus sign. This tells you, hey, you're fixing to divide by that. That's all it's saying. It's really not any harder than what we were doing. So I see my minus sign, I see my minus sign, so I'm dividing by the y. And I'm done. That is my answer. All right, let's look at G. Now I see 2 minus signs. So that already tells me I'm going to have 2 things in my denominator. That's what that tells me, just so you know. All right, look in front. Anything there? Nope. Anything there? Nope. Oh, yep, there is. I'm going to have to fix that one. All right, so we're going to have to rewrite. So log base 4 of 3 minus log base 4 of 2 minus log base 4 of x to the 5th. I've got to take that coefficient 5 and bring it and let it become the exponent of the argument. Okay, they all have the same bases. All right, so since there's really a plus sign in front of the first one, it's log base 4 of 3, and 3 is in the numerator. Now there's a minus sign on the next one, so that's going to be divided by 2. There's a minus sign on the last one, so we're still dividing, so it still is going to stay in the denominator. If it's a minus in front of it, you're still dividing, you're still in the denominator. So that's going to be x to the 5th. Done. That one looked long, but it really was one of the shorter ones. All right, now we're going to go backwards and we're going to expand. So I was thinking we were going to expand tomorrow, but we're going to go ahead and expand some today as well. All right, I paused the video for a minute so I could just clear my paper because I want to go back up here to this box. I said I was going to do this tomorrow, but I'm doing it today. What we're going to do is we're going to talk about expanding. So with expanding, if you're looking at this box, you're starting on the left side and you're going to the right. You're going to take what was concise, okay, and single, and you're going to make it into more. So you're going to add plus signs and stuff to it. So log base b, you write log base b. Then you do of m first. All right, since they're being multiplied, you put the plus sign. You write log base b again. And now it's of n. All you're doing is expanding a single logarithm. All right, let's look at the next one. You have your log base b. This time it's m over n, so you know you're dividing, so you know you're going to have a subtraction sign. Log base b of m is what you write first, log base b of m. Subtract log base b of n, log base b of n. So it should make sense because you're just reversing what we were just doing a while ago. Now, for the last one, the power one, when you have the power, what you're doing is you're taking the power and you're just putting it in front as a coefficient. All right, so that explains the expanding of logarithms. All right, so we're going to go down here to the bottom of the page where it says expand. So they are giving you a single logarithm and they want you to expand it. All right, the first thing I kind of look for is there an exponent right here? There's not in this one, but looking ahead, there is in that one. So we're going to already do something different for these two, but they're still going to be kind of the same. So you write log base 6, and you're going to write the 3 first. Now, since all three of those are being multiplied, you're going to have plus signs in between. Then you're going to write log base 6 of x. So we've done the first one. We've done the second one. Plus log base 6 of y to the 5th. All right, so we're almost done. Now, do you see that y to the 5th? When you're expanding, you cannot have exponents. All right, so you're going to have to take that 5, and you're going to take it and you're going to put it in front of this one. So it's going to look like this. Log base 6 of 3 plus log base 6 of x. Plus, you're taking the exponent or the power and you're putting it in front. It becomes the coefficient. So 5 log base 6 of y. All right, and that's the first one. All right, the next one. Now, there's two ways you can do this one. You can just automatically, right off the bat, go and put that 3 in front if you want. Or you can wait. Okay, either way. So I'm going to go ahead and put it out in the front. 3 log, we know it's a base 10, of 5x. All right, so now we're going to spread this out. We know that this is still a 3 log, okay, and this is base 10 of 5. And then since the 5 and the x are being multiplied, you're going to put a plus sign. You're going to put the coefficient 3 again, 3 log base 10 of x. All right, that's one way of doing it. I'm going to show you another way, so if you end up doing it this way, you don't feel like you're doing something wrong, okay? All right, so we see they're both being multiplied, but they also both have a power. So if I put log base 10 of 5, I have to put it to the third power. This is me not addressing this first. That's the only difference. I'm going to address it last. Since they're being multiplied, plus sign, log base x of to the third power. The reason why I tend to address the 3 first is because a lot of the time students forget to put the 3 as the power for both of them. So that's why I tend to address it first, because that usually takes care of that mistake. All right, now we're going to have to take that 3 and go put it in front. So 3 log base 10 of 5 plus 3 log base 10 of x. So you see you get the same answer either way. All right, let's do C, and then we're going to go to the back. All right, so we have log base 3, and it looks like I am dividing. But take note here that you're multiplying first. So log base 3 of 4. Now I'm multiplying the 4 times the x, so I have to put a plus sign. Write the log base 3 again, this time of x. All right, now I'm finished multiplying, so I'm dividing, so I'm going to have to put a minus sign, but I'm still using log base 3 of y. Done. All right, let's turn it over to the back. There's D. That's the one we're going to look at next. All right, we see we're dividing, but if we look at the top one, there's going to be a plus sign for this one because it's in the numerator. So log base 2 of 3. Now we're going to do a subtraction. Minus log base 2. We're going to do the 7 first. Now we're still in the denominator, so we still do a minus. So minus log base 2 of y. I'm just going to stand back and check. Do I have any coefficients? Nope. Then I'm done. All right, E. Now this one looks a little bit different. Okay. We see that the 6 is out in front of the x plus 5 cubed. Now that 6 is really just being multiplied by that. Okay. So you're going to pretend like this is being multiplied by this, which is what's happening. I don't want you to think of it as you have to distribute or anything. This is still log base 10 of 6. All right, we've taken care of the 6. Okay, now because they're sitting side by side, that means we're multiplying, so we're going to use a plus sign. So we're going to do log base 10 of x plus 5 cubed. All right, we're almost done. There is an exponent though, and we can't have an exponent. So we're going to take that exponent, if you remember, and we're going to take it and we're going to go put it right in front of this log. So log base 10 of 6 plus 3 log base 10 of x plus 5. All right, we don't have any more exponents. We have a coefficient now, so we're done with that one. All right, last one. This one's going to be a little bit longer. Now remember, you're multiplying these two. So this is going to be log base 5 of 4. You're multiplying, so a plus sign. Log base 5 of the square root of 7m cubed. All right, so that looks a little bit different. So what we're going to have to do here is we're going to have to change that square root to what's the opposite of square root? Remember, if we did square root earlier, we did the square root of x, that really equaled x to the 1/2. Okay, so recall that because we're going to do kind of the same thing. So let's just rewrite here. Log base 5 of 4 plus log base 5 of, now we're going to take that 7m to the third and we're going to put it to the 1/2. Okay, because the square root equals the exponent of 1/2. All right, so let's rewrite again. Log base 5 of 4 plus log base 5. Now look at it. That is really going to be 7 to the what? What we're going to go ahead and do now is we're going to take that 1/2 and we're going to go put it in front and make it a coefficient. All right, so we're going to put, let me erase my plus sign, give us a little bit of room here. Plus, we're going to put 1/2 in the front and we're just going to leave it as 7m cubed. All right, so let's see, what else do we need to do? Well, the 7m cubed basically just needs to be separated out because anything that's being multiplied has to be separated out and a plus sign has to be put. So we're going to do log base 5 of 4 plus 1/2 log base 5 of 7. All right, put your plus sign. Do that 1/2 again. 1/2 log base 5 of m cubed. All right, that looks pretty good. Now there's one more step we're going to do. And we actually could have done this step earlier. So I may go back and show you. And then if you don't want to watch it, you don't have to watch it. But I want to at least get you to the end of this problem because we're not quite done. You see how we still have an exponent? Okay, right here. We can't have that. You take that exponent, okay, and you're going to multiply it by 1/2. So it's going to be log base 5 of 4 plus 1/2 times log base 5 of 7 plus 3/2 log base 5 of m. All right, now we don't have any more exponents and nothing else needs to be separated out into addition and division. But we could have done this differently. I'm going to show you where we could have done this differently at because you might like it this way better. So let me erase a little bit. Then erase all the way up to here. So you can just watch this one. You don't have to write it if you don't want to, unless you like it. And then you're like, okay, write it then. I'm going to go ahead and write log base 5 of 4 plus log base 5 of, now that's going to be 7 to the 1/2. Does everybody see that? 7 to the 1/2. All right, now I put my plus sign. Log base 5 of m to the, see how the 3 times the 1/2 here is going to get you 3/2? So a lot of people like it this way because really it makes it one less step. All right, then you're going to put log base 5 of 4 plus log, oops, let me erase that because we're going to take our exponent, you circle it in green, we're going to take it and we're going to go put it in front and make them coefficients. And this actually takes away one extra step. So 1/2 log base 5 of 7 plus 3/2 log base 5 of m. So if you look at that and you look at the answer we got a while ago, that's the same thing. So a lot of people like to go ahead and take care of doing this part and changing it. Because remember, this is 7 to the 1. So 1 times 1/2, that's how we got that 1/2. And then 3 times 1/2 is going to be 3/2. All right, that's it. So let's see. I'm going to go ahead and write your homework down on here just in case saves you from having to look it up, right? So your homework is going to be page 466, problems 9 through 21 odds, and 23 and 27. All right, so page 466, 9 through 21 odds, 23 and 27. So you're going to do that, and then I guess I'll just see you tomorrow. You guys have a good Monday. Bye.